Hello, welcome once again to another discussion on motion. Right now, we want to look at the acceleration due to gravity. We want to look at acceleration due to gravity. Okay, we are going to look at it at the surface of the Earth, at the surface of the moon, and at the surface of the sun. Okay, we are going to look at it in that area. Now, we have the one of the Earth. Over the years, students have been asking, sir, how come that value 9.8 or the 9.8 meter per second square or approximately 10 meter per second square? Because from 9.8, we have 10 meter per second square. That is the value for G, which is the acceleration due to gravity. But today, we are going to solve that question. No student quest. Some of them are eager to learn. They have that, they are so inquisitive. Of course, they are so inquisitive. They want to know, they want to know. Today, students, don't forget, you are going to understand or you will really know how we obtain that value, 9.8 or approximately 10 meter per second square. Now, we want to look at the one of the Earth. In the first place, we want to look at the one of the Earth. Please don't forget the Earth orbits around the sun. The Earth orbits or revolve around the sun. All objects attract one another, including the Earth and the sun. The force of this attraction or gravitational pull depends on the size of the object. As the sun is very large, it exerts a great gravitational force on the Earth. Okay, as the Earth rotates, it also moves. Please don't forget, as the Earth rotates, it also moves or revolves around the sun. Okay, now looking at acceleration due to gravity at the surface of the Earth. Looking at acceleration due to gravity at the surface of the Earth. Now, for what we have here, you can see the mass of the Earth. This is the mass of the Earth, and this one is the radius of the Earth. Can you see it? The mass of the Earth and the radius of the Earth. Now we have all the information on the board, meaning we cannot determine acceleration due to gravity at the surface of the Earth. Now, suppose this is the Earth, this is the Earth, and we do know that this Earth will exert a weight force. The weight force, which is W, please don't forget the weight force, which is W, downward, and it's always the downward force. And there is a force of gravity acting upward. Now, in this one, on this body now, it means that there will be a net force. Meaning, in this body, there will be what? A net force. A net force. Net force. Please don't forget net force. Net force. Let us now look at determine this net force. To determine this net force, and the only component that affects it is going to be y component. And you see what now? We have the F, which is positive, and the W is negative. Now, here is 0, with the sum of the four net force, 0 there. And here become F minus W. Now, taking it over, F becomes equal W. Can you see? F becomes equal W. Where you have F is the gravitational force. Please don't forget, where you have F is the what? Gravitational force. And the W there is the weight force. The W is the what? The weight force. Now, to do this, now what can we really do? And don't forget that the gravitational force is simply G, which is the mass of Earth. You know, there are two masses of Earth. Okay, it means that here is going to be what? Mass of the Earth square all over the radius, the square of the radius of the Earth. Okay, that is for the force of gravity. Now, for the weight force, and we are having what? Mass of the Earth, which is G. Please don't forget, for the weight force is mg. Since we are dealing with the Earth, it becomes me, which is the mass of the Earth, g. Now, therefore, this can kill one of these. Now, what do we have there? We have our g to be now, and that is me, which is the mass of the Earth, all over the radius, square of the radius of the Earth. Okay, square of the radius of the Earth equal g. Okay. This is what we now have. Now, on the G we are looking for, that is the formula we are going to apply to determine our G. Now, to determine our G now, what can we really do? What can we really do? Let me put it here. You know our G is always constant and is what? 6.67 exponent minus, which is 11. Now what's our mass? The mass of the Earth from what we have there. The mass of the Earth, okay. What do we have there? We're having, okay, the mass of the Earth from what we have here, we have 5.98 exponent 24. Exponent 24. Please don't forget this is our G. This is our G. Please don't forget that. This is our G. Okay, this is our G. Now, what is the radius of the Earth? The radius of the Earth is simply 6,371 kilometers. We don't want kilometer. We need to convert that, and to convert it to meter, we are going to have 6.371 exponent 6. Okay, this is what how we convert. This is what you have when you convert. Okay, now for what we have here, let us see what we are going to have there. Let us see. Do you know that this very one I can as well approximate? I can as well approximate. Now if I approximate it, what is it going to give us? You know what it will give us there? You really know? Okay, let me not leave it like that way. Let me not leave it that way. Now multiplying it now, let us use our calculator and multiply. Okay, please don't forget this one is 24. Okay, that one is 24 there. Okay, this one is minus 11. Okay, okay, yes, we are very much correct. Now, to do that, to multiply with our calculator here, we have, okay, using our calculator, we have from the calculator here, we have, that is 3.9866 exponent 14. We're having 14 there. Now we'll still do the one which is this, which also use your calculator. We have here, we have 6. Yeah, okay, sorry, we have 4.07044 exponent 13. You can use your calculator and do that. Use your calculator and do that. Multiply this, you have this. This is what you're going to have when you use your calculator. And we also do this one with the squares, you have this. You mean that this one will be our value. This will be our value. Now, using the same calculator, we are going to divide. We want to divide, and when you divide that, we are going to be having here, we're having our G is now from the calculator, our G is 9,080,592,776,15. This is what we have. Meaning the value we have a very long value there. It means that when you use your calculator, this is what you are going to have. Now, I want to now approximate. Do you know that in some cases we have it to be DG? DG we have here now, we have it to be 9, that G is given as 9 point. When you make it to one decimal place, you make it to one decimal place, you are going to have it here. And 1 plus is round up, and which is 1. Having it here become 8, which is 9.8. 9.8, meaning here is 9.8 meter per second square. Or make it to the nearest whole number. And what is the nearest, what is the whole number then? 9, what's close is 7, is round up, add it here become 10. We can also see approximately, this is also approximately 9.8 or approximately 10 meter per second square. This is how we get or obtain the value for G. This is how we obtain the value for G. I hope you understand it. Please, it's very clear. What we need to do there is to obtain the formula for this derivation. And we have the formula there, which is, I hope you can see there, which is the gravity with gravity multiplied by the mass all over the square of the radius of the earth equal g, and that is the value, that is the formula we use to obtain that value 9.8 meter per second square. You can even see when you were multiplying, you simply just carry them, put them at their position, and after which multiply. And also for the one of the radius, you can see having square, I also square it and divide it, and you are going to have that value. Just use your calculator, you will definitely have the value. Okay, I hope it's clear, very, very clear. This is how we obtain this value 9.8 meter per second square, or approximately 10 meter per second square. Please take notes, very, very important. Take notes, okay, take notes, very, very important. Take note, very, very important. Okay, I think at this point we can stop, and so that we can move on to the other area, which is the one at the surface of the moon, the one at the surface of the moon, and the one at the surface of the sun. Thank you for joining me once again. God bless you.